Okay, so to find out the force AC and the force CB, your first step is we should draw the free body diagram for the given system. Okay, so this is the physical system given where this lamp is hanging with the help of these two cables. Okay, so here you can isolate this lamp or you can isolate the point C. Okay, so suppose you isolate this lamp. Okay, then you should show the forces acting on the lamp. So your first force will be at the point C. This is the force in the cable BC. So this is the force BC. Okay. Second force will be the force in the cable AC. And there is a third force on this lamp. It is the self weight. Okay. So this weight, it will act exactly in the downward direction. So this is equal to 150 Newton, which is given in the problem. Okay. Or you can draw the free body diagram just for point C. Okay. Because point C, it is the point of concurrency. Okay. So you can draw the free body diagram like this. Just draw the point C. This is the first force. This is second force. And self weight is the third force. Okay. So you can draw the free body diagram like this. Okay. So after this, we have to find out the angle of inclination. Okay. So this 3/2. So let us take this as alpha. So this is tan inverse 3/2. So this is equal to 56.31 and take this as a beta. So beta is equal to tan inverse 8/3. So this is equal to 69.44. Okay. So these angles, they are given with respect to one horizontal line. So this dotted line you can assume as a x-axis. Okay. So this angle is alpha, this angle is beta. So on this diagram, you can draw the reference line. So this will be your x-axis. So this is your beta angle, which is 69.44. Then this is 56.31. Okay. This vector is perfectly vertical, so it is in the negative y direction. Okay. Now these are the unknown FAC and FBC. So as there are two unknowns in this system, we must have two equations to solve the FAC and FBC. So for equilibrium of concurrent forces, we have the condition for equilibrium. One is summation Fx0 and second condition is summation Fy is equal to 0. Okay. So by using these two conditions, you can find out these two unknowns. So before that, we have to resolve these two forces, FBC and FAC. Okay. So for the resolution, you can show the component at this point, or you can select the other point on the line of action. So select the point on the line of action. So this is the x component and this is the y component. Okay. So this 69, that means this angle will be 69. So your x component will be FBC. So this component is adjacent component. So it's cos 69. Okay. And this is the opposite component. So this is the sine component. So this is FBC sine 69.44. Okay. So this is the resolution for the force FBC. Now resolve the FAC. So select a point on this line of action. Draw the vector which is parallel to x-axis. So this is the x component. Draw the vector parallel to y-axis. This is 56. So this angle will be same 56. Now this component is the adjacent component. So it is a cos component. So force is FAC cos 56.31. Okay. And this is the opposite component. So it is a sine component. So this is a FAC sine 56.31. Okay. And 150 Newton, no need to resolve this force. It is in the negative y direction. Now use this equation, summation Fx0. So summation Fx is equal to 0. So consider FBC cos 69 so it is positive x direction. Second is FAC cos 56.31. So it is a negative x direction. So minus FAC cos 56.31. Okay, only two forces in the x direction. So this is equal to 0. Okay. Now use the second condition, which is summation Fy is equal to 0. So for summation Fy is equal to 0, we have FBC sine 69.44 plus FAC sine 56.31. Both are in the positive y direction. Okay. So FAC sine 56.31. And there is one more force, which is a 150 Newton. So 150 Newton in negative y direction. So it is minus 150 equal to 0. Okay. So just I will write the values. So find out these values and write the equation. So this equation we can write as so this point 35 FBC minus point 55 FAC equal to 0. Okay. So this is the first equation. Write the second equation. So sine 69.44. So this is 0.94 FBC plus 0.83 FAC, and just shift this 150 on the right hand side. So equal to 150. Okay. So this is your second equation. Now these two simultaneous equations we can solve directly in the equation mode of your calculator. Now to solve these two equations 1 and 2, select the mode, select the fifth equation and select the first option. Okay. So this is the two variable equation. Now here A, B, these are the coefficients of ABC and FAC. Okay. So first 0.35, then second minus 0.55, and the constant C, it is on the right side. Okay. So it is 0. In the second equation, we have 0.94, then 0.83, both are positive. And this constant, it is minus 150. You should take this on the right side. Okay, so it is a plus 150. Okay, so once you enter all the values A, B, C, then press equal to sign. So this is your first value. So this value X is nothing but ABC. Okay, so your answer is 102.16. So ABC is 102.16 Newton. Then second value, again press equal to. So if you get the values in the fraction, then you have the option SB. Okay, so press this, the fraction gets converted to decimal places. So it is 65.015. So this is FAC. Okay, it is 65.015 Newton. Okay, so this is your final answer. So these are the two unknown values or the unknown forces in the cable AC and BC. Okay. So any concurrent force system problem for the equilibrium, you can solve by using these two conditions, summation Fx0 and summation Fy0. Okay. So the first step will be we have to draw the free body diagram. Okay. And once you draw the free body diagram, then resolve the forces which are inclined. Okay. And then write summation Fx equation, summation Fy equation, and then you will get the unknown values. Okay, so note down the second example. So here a sphere of weight 1000 Newton and the radius 2 meter, sorry, 20 centimeter, or this is 0.2 meter. So it hangs by rope AB and its length 40 centimeter. And that sphere rests against a vertical wall as shown in the figure. Okay, determine the tension in the rope. And the reaction at point C. Okay, so this is the contact point of that sphere with the vertical wall. Okay, so this is the point C. This is the cable AB. Okay, so you have to find out the tension in the cable or in the rope AB and the reaction at point C. Okay, so for this, your first step will be you should draw the free body diagram. So in the free body diagram, just isolate this sphere from its surrounding. Okay. So the sphere is in contact with this vertical wall and it is supported with the cable AB, which is connected at the center point. Okay. So here I will just draw the sphere. Okay. Now show the forces on the sphere. So the first force will be its own weight. Okay. So it is given in the problem. So this is 1000 Newton. Okay. So weight always act in the y direction. So this is the weight force, which is 1000 Newton. Okay. Second force will be here. You can see it is supported with this cable AB. Okay. So this cable will have the tension. So you can draw that vector. So this is the tension in the cable AB. Okay. Or you can write this FAB. Okay. So this is the second force. And the reaction is at point C. Okay. As it is supported by this vertical wall. So this wall will offer the reaction like this. So this wall will try to push the cylinder or the sphere in the rightward direction, okay, or along the positive x direction. So we have to show this reaction at this point. Okay, and this reaction will exactly pass through the center point. Okay, so always remember, if you have the wall vertical or horizontal, and if the cylinder or a circle or sphere is in contact with the wall, okay, then the reaction offered by the wall, it will always pass through the center point. Okay, so similarly here you can show the reaction. So this reaction is RC. It will pass through the center point. So the point is B. Okay, so this is your complete free body diagram. Okay, now from this free body diagram, you can find out the unknown values. So unknown values are tension AB and second is the reaction RC. So you have two unknowns. So you should use two equations. First is summation Fx0 and second equation will be summation Fy0. Okay, so before that we have to resolve the forces. So we have to resolve only one force because reaction RC is exactly in the horizontal direction. It is passing through the point B. Okay, and the weight W in the y direction. So just resolve the tension AB. So I will select the point on the line of action. So this is the x component and this is the y component. Okay, just this angle is not given. So you have to find out this angle from the given dimension. So this length of the rope and the diameter of the sphere is given. Sorry, radius is given. Okay, so from this, find out this angle. Just take this alpha. Okay, find out the component. Then put the value in summation Fx, summation Fy, and get these two values. Okay, so try to complete this as a homework.